March 6, 1944, 28,000 feet above Berlin. The 56th Fighter Group engaged German fighters in what would become the largest air battle yet seen over Europe. Across the sprawling combat, American Thunderbolt pilots discovered something that shocked their Luftwaffe opponents. German fighters executed their standard escape maneuver, pulling into steep climbs to evade pursuit. For the past year, this tactic had been nearly foolproof. The heavy P-47 Thunderbolt simply could not follow a climbing Focke-Wulf 190 or Messerschmitt 109. But on this March day, something had changed. American fighters stayed locked onto German tails through climbs that should have been impossible. At altitudes approaching 28,000 feet, with both aircraft near stall speed, Thunderbolt pilots opened fire. Black smoke trailed from stricken German fighters as pilots bailed out. By mission's end, the 56th Fighter Group claimed 11 German aircraft destroyed without losing a single Thunderbolt. The transformation was complete. A modification to the Thunderbolt's propeller had eliminated the aircraft's most critical weakness and fundamentally altered the tactical balance over Europe. The story of this transformation began in the engineering departments of two American propeller manufacturers during the brutal winter of 1943. While bombers bled over Germany and fighter pilots filed reports describing German fighters escaping by climbing away, engineers raced to solve a deceptively simple problem. The Pratt & Whitney R2800 engine produced 2,000 horsepower, yet the P-47 Thunderbolt climbed poorly. The narrow-blade Curtiss electric propeller fitted to early production models could not convert that massive power into vertical performance. These blades were designed for high-speed cruise efficiency, optimized for cutting through air with minimal drag above 350 miles per hour. During climbs at low air speeds with the engine at maximum power, narrow blades could not bite into enough air to efficiently convert horsepower into thrust. Engines screamed at maximum RPM, burning fuel and generating heat, but not pulling aircraft upward with sufficient force. In January 1943, at Republic Aviation Corporation headquarters on Long Island, Alexander Kartveli reviewed combat reports from England with growing concern. German fighters dove through bomber formations, attacked, then pulled into steep climbs to escape. Pursuing Thunderbolts could not follow. Performance data was damning. Early P-47 models required lengthy climbs to reach combat altitudes. The FT-190 Amperes and BF-109G reached those altitudes far more quickly. This performance gap translated directly into American casualties. Some Army Air Forces commanders even questioned whether the P-47 should remain in frontline service. Kartveli understood the engineering problem. Propeller efficiency depends on matching blade area to operating conditions. Increasing blade area seemed obvious, but proved complex. Every propeller design change affected the entire aircraft system: vibration, torque, weight, harmonics, control. All had to be balanced. Two companies competed to solve it: Curtiss-Wright, maker of the original propeller, and Hamilton Standard, a major supplier for other U.S. aircraft. Both knew that the winning design would be built in tens of thousands of units, determining the survival of thousands of American pilots. Hamilton Standard's engineers developed a radical paddle blade propeller, wide, almost rectangular blades that grabbed air like oars through water. Curtiss-Wright countered with a broader elliptical design featuring blade cuffs to smooth airflow. Both offered huge improvements. Testing began in April 1943 and showed similar results: dramatic increases in climb rate with only minor losses in top speed. The Army approved both. Hamilton Standard propellers would equip new P-47D2 models from Farmingdale, while Curtiss props would retrofit earlier aircraft and those from Evansville. By December 1943, the first paddle-blade Thunderbolts arrived in England. Lieutenant Colonel Hubert Zemke of the 56th Fighter Group quickly realized their potential. The P-47 could now climb with eagerness once thought impossible. He retrained his pilots around new vertical tactics, spiraling climbs, energy retention dives, and high-altitude re-engagements that would have been suicidal months earlier. By early 1944, German pilots began reporting Thunderbolts that could climb with them. Many thought they faced a new aircraft. Confusion reigned until a downed P-47 revealed the new wide-blade propeller. Luftwaffe analysts initially dismissed it as an improvement for takeoff, not realizing its full significance of fatal oversight. Through January and February 1944, more groups transitioned to paddle blades. By March, 6 of 8 Thunderbolt groups in England flew the upgraded fighters. In combat, German escape tactics failed. Luftwaffe units like Jagdgeschwader 26 suffered severe losses as standard climb-away maneuvers led straight into the guns of pursuing Thunderbolts. During Big Week, in February 1944, a massive bombing campaign targeting German aircraft factories, the effect was decisive. U.S. fighters flew over 3,600 sorties and destroyed more than 350 German aircraft for just 28 losses. The balance of air power had shifted. Thunderbolt pilots like Francis Gabreski perfected new climbing spiral tactics, forcing German fighters to bleed energy in vertical turns before reversing and striking. Gabreski became America's leading ace in Europe, flying the P-47, crediting the paddle-blade propeller for his success. The engineering achievement lay not in complexity, but in speed. In just 9 months, American industry identified the problem, tested solutions, mass-produced both designs, shipped them overseas, and trained mechanics for installation, a logistical triumph Germany could not match. By D-Day, in June 1944, paddle-blade Thunderbolts dominated the skies. They intercepted German fighters before they reached Allied forces, destroyed aircraft on the ground, and provided near-continuous cover over Normandy. Luftwaffe pilots who once mocked the flying bathtub now feared it. Kill ratios told the story. Early 1944, 1.8 to 1. Mid-1944, 3.2 to 1. Late 1944, 4.6 to 1. Improved thrust also enhanced acceleration, climb recovery, and turning energy, transforming the Thunderbolt from a lumbering escort to a versatile dogfighter and ground attack powerhouse. Even as the P-51 Mustang took center stage, many elite groups like the 56th refused to give up their Thunderbolts, calling them tougher and more adaptable. German ace Günter Rall later admitted that the new Thunderbolt had to be treated like a Mustang. By late 1944, paddle-blade P-47 seconds were carrying bombs, rockets, and external fuel tanks while maintaining impressive agility. They flew over 88,000 attack sorties that summer, suffering less than 1% losses. From concept to battlefield, the paddle-blade propeller epitomized American industrial efficiency, solving a deadly problem through practical, scalable engineering. While the innovation faded into obscurity as jet fighters took over, its lesson remains timeless. Wars are not won by miracle weapons, but by thousands of small, smart improvements executed quickly and at scale. The paddle-blade Thunderbolt was one of those quiet revolutions, an unsung mechanical upgrade that helped turn the tide of the air war over Europe. After D-Day in June 1944, the paddle-blade Thunderbolts continued to shape the air war across Europe. Throughout the summer and autumn, they flew relentless missions against German transport, communications, and armor. Their improved low-speed thrust allowed them to dive and climb out of ground attacks with speed and safety previously impossible. Statistical evidence supported what pilots already knew. In the first quarter of 1944, before paddle-blade propellers became widespread, American fighters in Europe achieved an overall kill ratio of approximately 1.8 to 1 against German aircraft. By the second quarter, with most American fighters equipped with paddle blades, the kill ratio improved to 3.2 to 1. By the third quarter, it reached 4.6 to 1. These improvements were not due solely to the new propellers. American numerical superiority was growing, pilot training was improving, and Germany was fielding less experienced replacements, but combat reports made clear that improved climb performance played a critical role. The Curtiss Electric C542S paddle blade propeller, the most widely used variant, featured 4 blades with a 13-foot diameter. Each blade had significantly greater surface area compared to its narrow blade predecessor, translating to vastly improved thrust at lower air speeds. The Hamilton standard Hydromatic paddle blade, fitted to later production P-47 seconds, offered similar performance with simpler and more reliable hydraulic pitch control. Both designs delivered nearly identical combat results, and both became vital elements of the Thunderbolt's transformation. Manufacturing these new propellers demonstrated the scale of American industrial power. Both Curtiss-Wright and Hamilton Standard produced thousands of assemblies between June 1943 and December 1944. Each assembly contained 4 blades, a hub, a pitch control system, and mounting hardware. Every blade was forged from aluminum alloy, carefully machined, and heat-treated for strength. Transporting these massive propellers to the front was itself logistical victory. Each weighed about 650 pounds and had to be crated, braced, and shipped across the Atlantic. Once in England, depot mechanics installed them, each retrofit taking roughly 16 hours per aircraft. Between January and June 1944, more than 1,000 Thunderbolts were upgraded in theater, while combat operations continued uninterrupted. By late summer 1944, Thunderbolt pilots had adapted new tactics that fully exploited their improved performance. One of the most effective was the vertical scissors. In this maneuver, 2 Thunderbolts worked together in a climbing dogfight. As a German fighter tried to climb away from one, the second would be waiting above or behind, ready to strike as the enemy stalled. The Luftwaffe's standard escape climb now led directly into a trap. German pilots faced a brutal choice: continue climbing and risk stalling, or level off and face a diving Thunderbolt from above. The same improvements also made the P-47 even deadlier in ground attack roles. With the extra thrust at low speed, Thunderbolts could haul heavier bomb and rocket loads without losing maneuverability. They could dive from lower altitudes, strike with precision, and climb out faster, reducing exposure to anti-aircraft fire. Between April and September 1944, Thunderbolts flew more than 88,000 ground attack sorties and lost fewer than 1% of their aircraft, a stunning statistic in one of the most dangerous missions of the war. Many fighter groups that received P-51 Mustangs later in the war still chose to keep their Thunderbolts. The 56th Fighter Group, led by Colonel Hubert Zemke and later Colonel David Schilling, flew P-47 seconds exclusively to the end of the conflict. The pilots valued their aircraft's toughness, heavy armament, and now, thanks to the paddle blade propeller, its excellent climb and combat agility. German aces who survived the war confirmed these impressions. Major Günther Rohl, with 275 victories, later said that the improved Thunderbolts were far more dangerous than the early ones, and that Luftwaffe pilots had to treat them with the same caution as Mustangs. The engineering lessons from the paddle blade program influenced aircraft development long after the war. The project proved that rapid, practical innovation could be more effective than long theoretical perfectionism. It showed how direct feedback from combat pilots to engineers could change the course of a campaign. By late 1944 and early 1945, water methanol injection systems were added to the R-2800 engines, temporarily boosting power to more than 2,500 horsepower. Combined with the paddle blade propeller, this made late-model Thunderbolts, such as the P-47M, some of the fastest climbing piston fighters of the war. The cost of this entire development program, from design to deployment, totaled around $3 million, tiny compared to the $100 million or more that developing a brand new aircraft would have required. The Thunderbolt's transformation was the perfect example of American wartime problem-solving. Identify a weakness, design a simple but effective fix, and execute it with unmatched industrial speed. By the winter of 1944, the paddle-blade Thunderbolt had become a symbol of American air dominance. Its final great test came during the Battle of the Bulge. In December 1944, German ground forces launched a desperate surprise offensive through the Ardennes. For several days, bad weather grounded most Allied aircraft, allowing German armor to advance. But when skies cleared on December 23rd, Allied air power returned with overwhelming force. Paddle blade-equipped Thunderbolts flew hundreds of sorties every day, striking tanks, supply lines, and troop columns. Their improved climb and thrust allowed them to attack, pull up through steep ascents, and circle for another run, faster than ever before. Luftwaffe fighters tried to interfere, but they were consistently driven off. By February 1945, organized German air resistance in the West had largely collapsed. Fighter units were pulled back to defend what remained of Germany's industrial heartland. The Thunderbolts and their paddle-blade propellers had played an enormous part in achieving that air superiority, though history often credited the Mustang instead. The truth was that the transformation of the P-47 came at a critical time when the Luftwaffe was still strong enough to inflict real losses, and the Allied bombing campaign's success was far from certain. Between January and December 1944, Thunderbolts were credited with destroying more than 3,800 German aircraft in aerial combat, while losing about 824 of their own to all causes in the European theater. The overall kill ratio of nearly 4-to-1 matched or exceeded that of any American fighter. Perhaps most importantly, the P-47's transformation from a poor climber to a high-altitude predator occurred precisely when it was needed most. Without the paddle blade program, the Allies might have lost hundreds more bombers and delayed the destruction of German air power by months. After the war, as jet fighters entered service, the Thunderbolt quickly faded from memory. Many were scrapped, others sold to foreign air forces. The remarkable engineering achievement of the paddle blade propeller, the simple, practical fix that changed the P-47 from a sluggish brute into a deadly champion, was soon overshadowed by the jet age. Yet its legacy endured. The program proved that small, well-targeted improvements could have massive effects when executed efficiently and at scale. It was a triumph not of revolutionary technology, but of intelligent, incremental progress. American engineers, mechanics, and factory workers collaborated across continents to identify a problem, design a fix, and implement it in less than a year. That collaboration, and the logistical might behind it, was what truly distinguished Allied air power from the Luftwaffe's increasingly desperate efforts. German engineers understood propeller theory just as well as the Americans, but by 1944 they lacked the resources, factories, and time to act. Their perfectionism and shortages doomed their efforts to catch up. The paddle-blade Thunderbolt stood as proof that wars are not won by miracle weapons alone, but by 1,000 well-executed solutions. Each improvement, each faster climb, safer takeoff, and smarter design added up to overwhelming superiority. When the skies over Europe cleared in 1945, Allied victory owed as much to quiet engineering successes like the paddle blade propeller as to any famous aircraft or ace. The P-47's evolution was not glamorous, but it was decisive. From the engineers in Connecticut and New York who reshaped the blades, to the mechanics in muddy English airfields who bolted them on, to the pilots who climbed into the clouds over Berlin, the story of the paddle blade Thunderbolt remains one of the most important yet least remembered triumphs of the air war.